In order to reinforce a key concept in science and experimental design, let's briefly cover how we study the effects of drugs on the brain and behavior. Specifically, we will review the scientific method and the distinction between independent and dependent variables. As you likely know, the scientific method is the systematic pursuit of knowledge. This is a historically recent concept. From the lens of Western civilization, the Dark Ages in Europe almost wiped out all scientific knowledge that was originally created in Greece and Rome. During the Dark Ages, Roman scientific concepts survived in monasteries and cathedrals until the Renaissance. Thus, while science and religion are often billed as being at odds, it is true that European science would not have survived without the Church. The Dark Ages ended with the emergence of the Renaissance. During this period, a lawyer and philosopher known as Francis Bacon observed the scientific experiments of Copernicus and Galileo Galilei, in which these notable scientists changed our views of the cosmos and our place in the universe. These observations led Francis Bacon to formally propose a new approach to scientific inquiry, which we now call the scientific method. The scientific method generally includes making an observation that can lead to the generation of a question, such as Galileo built the first telescope to make observations in space. Then, two, you need to generate a testable hypothesis. For example, based on his initial observation, Galileo decided to test Copernicus's idea that other planets actually revolve around the sun rather than the Earth. Then you generate predictions. For example, Galileo's initial results supported Copernicus's hypothesis. Some of these include, he demonstrated that Venus has light phases from our perspective, which would be impossible, especially for Venus to be fully illuminated, unless both Venus and the Earth rotate around the sun. He also observed that Jupiter has moons that rotate around it. These discoveries, amongst others, seem to support the theory that the sun is the center of the solar system, and the moon rotates around planets that in turn rotate around the sun. From these proclamations, the Catholic Church did imprison Galileo. In fact, one of my favorite memories of Florence, Italy, is the fact that Galileo's middle finger is on clear display all by itself in a big glass jar. Of course, this is, while a coincidence, the irony of the situation is, a little funny to me as a scientist. But of course, it is only funny and notable because his results stood the test of repeated retests. Science is never a single result that brings finality. Rather, it should be thought of as a game of percentages. If you were to swing a bat at a baseball, you might end up hitting the ball 1 out of every 3 times. Repeated testing would be necessary to derive your batting average of 333. And on any given day, you might hit 1,000 or 0. But the question is, what is most likely to occur with repeated testing? In this case, Copernicus's hypothesis and Galileo's observation stood the test of time. There is now incredibly substantial evidence that the sun is indeed the center of our solar system. But that doesn't mean we should stop evaluating the hypothesis either. Often the answer or results come with great nuance. What is Pluto, for example? Does it revolve around the sun? Does that make it a planet or a moon? Maybe we need to refine some definitions, as was done recently to shift Pluto into a nuanced category of a dwarf planet. And how exactly how cylindrical are these orbits? Are we really circling the Earth in circular orbits? Thus, maybe we shouldn't cringe the next time a famous athlete says something like, about a flat Earth or the Earth being the center of the universe. In fact, they are, in a way, participating in the scientific process by challenging us to use advances in technology to better support our hypotheses and preceding results. Importantly, the result of the scientific method is empirical knowledge, which is information that can be verified through observation and experimentation. As much as I enjoy thinking about the interactions of phytochemicals and neurochemicals in evolution, I am simply unable to design a hypothesis that allows me to test my speculations on this topic. Thus, this line of thought is more philosophical than scientific in nature. In this class, 90% of what I cover is going to be empirical in nature. It is also worth noting that the field of psychology has an interesting split of philosophy and empirical science in it. I am very much on the empirical science side of things and rarely work with philosophical concepts. In fact, I am usually highly critical of the philosophical side of psychology and, might even be, a little extreme in my views on that way. That being said, we would not have an empirical scientific method without philosophy. And Francis Bacon, a philosopher. Similarly, Galileo would not have upset the Catholic Church if preserved scientific and technical knowledge had not been saved by the Church. So, for fun, I have a quick analogy from a popular old TV show here that I'll show you next to demonstrate the scientific method.
Have you noticed that Howard can take any topic and use it to remind you that he went to space?
Interesting hypothesis. Let's apply the scientific method. Perform an experiment.
Okay. Hey, Howard, any thoughts on where we should get dinner?
Anywhere but the space station. I mean, on a good day, dinner was a bag full of meatloaf. But hey, you don't go there for the food, you go there for the view.
It's fascinating. Let me see if I can duplicate the result. Howard, I've always thought the lemon was an underrated fruit. Care to weigh in?
Not really.
Oh, well.
People say the Soyuz capsule is a lemon, but... Yeah, but hey, that baby got me to space and back.
In all experiments in the field of psychopharmacology, you will always have an independent and a dependent variable. A very common independent variable is drug dose. So we might want to test the effects of drug dose on a well-established cannabinoid effect. All cannabinoids are currently thought to produce 4 effects in experimental animals. This battery of effects is known as the tetrad test and was first established through repeated observation by Dr. Billy Martin at Virginia Commonwealth University. He concluded that all cannabinoids he tested produce 4 effects. They all produce hypothermia, analgesia, catalepsy, and hypoactivity. Hypothermia is a decrease in body temperature. Analgesia is a decrease in pain. Catalepsy is sort of a statue-like posture. And hypoactivity is just moving less. I'll also point out that cannabis catalepsy is very different than catalepsy produced by analeptics, like antipsychotics. Antipsychotics tend to produce a very sort of relaxed catalepsy. Extremely high dose full agonist cannabinoids produce a much more rigid catalepsy. It's very interesting to see the two and how they are distinct. But anyway, Billy Martin concluded that all cannabinoids produce these 4 effects. Thus, to test his established hypothesis, we might test how various doses of cannabinoids reduce body temperature, as in the case of hypothermia. And it is very important for the scientist to provide operational definitions and for the reader to pick up on them. In this case, I would define hypothermia as a significant decrease in core body temperature.